Instead of asking you to solve an equation or system of equations, the SAT sometimes asks simply for the number of solutions. Before you can answer that, you first need to ask yourself if the equations include an x squared. This is usually obvious, but remember that x squared terms can be buried in algebra steps like foiling and distribution. This lesson covers what to do when there is no x squared term in the question. Without an x squared, you almost certainly have linear equations. As a reminder, we really want to think about lines using the slope-intercept form, which you probably know better as y equals mx plus b. Remember that m is the slope of the line and b is the y-intercept. If you have two linear equations, then there are only three possible answers to the question. The two lines either have one solution, zero solutions, or infinitely many solutions. If you randomly generated two lines, it's very likely that they would have one solution or one point of intersection. This occurs when the two lines have different slopes. The y-intercepts could be the same, or they could be different. You can ignore the b term and just focus on the slope. If the slopes are the same, then you'll end up with one of the more uncommon situations. If the y-intercepts are different, then you'll have zero solutions because the lines will never intersect. But if the y-intercepts are also the same, then you have two versions of the exact same line. They literally have the exact same equation, so the two lines intersect at every point. This will often be described on the SAT as infinitely many solutions. Here are some examples of systems that fit each category. As you can see, the system with one solution has two completely different equations. Even though both equations use the numbers 3 and 5, they're in different positions, so the two equations have different slopes and different y-intercepts. But remember, it's the different slopes that tell us that the system has one solution. The system with zero solutions have different y-intercepts, but the slope's the same value of 2. The system with infinitely many solutions is just the same equation twice. However, it's very unlikely that the SAT will give you equations that are so obviously the same. In many cases, the SAT will jumble the linear equation so that the slope and y-intercept aren't as obvious. Remember to always get back to y equals mx plus b so that you can easily read the slope and y-intercept. It's very important that the y term is completely alone, with no numbers or negatives attached to it. The x side should be simplified so that it matches mx plus b exactly, with no parentheses or other components. If rearranging the equation is too annoying, then you can always graph the equations in Desmos to see what the lines would look like. If we graph the equations in the xy plane, we can see why the number of solutions is the same as the number of points of intersection. Systems with one solution will show two lines going in different directions. At some point, the two lines will cross, and the xy coordinates of that intersection point are the solution. There are no solutions when the lines never cross. This only happens when the lines are parallel. They go in the same direction forever because they have the same slope. But if they have the same slope and the same y-intercept, then the two lines perfectly overlap. On a graph, you would see the two lines as just one. Using algebra is usually faster and easier for questions asking about the number of solutions when there is no x squared, but you could put the two equations into a graphing calculator like Desmos if you want. At the least, it's a good way to check that you memorize these three situations correctly. But sometimes the SAT asks for the number of solutions by giving us just one equation. Again, if there's no x squared, then we can use the same rules for one solution, zero solutions, and infinitely many solutions. I recommend cutting the equation in two by just pretending the equal sign is a wall. You can see that on each side of the wall we have an expression that looks like mx plus b. Now you can easily compare the slopes and y-intercepts of each side. Notice that the equation with one solution has different slopes, the equation with no solutions has the same slope but different y-intercepts, and the equation with infinitely many solutions has the same slope and the same y-intercept. You might be tempted to solve these equations, just like in normal algebra, by moving terms across the equal sign to bring all the like terms together. I do not recommend this. In fact, when there are zero solutions and infinitely many solutions, solving the equation will produce a very confusing result that probably won't make much sense to you. It's safer and easier to pretend that the equal sign is a wall and treat each side like a separate y equals mx plus b equation. If you try using a graphing calculator in these situations, you will also get confusing results. When there's one solution, the equation will produce a single vertical line. The line tells you the value of the solution. But equations with zero or infinite solutions will look the same on Desmos. They will give you empty graphs with no lines at all. For this reason, if you're going to use a graphing calculator, my same advice still applies. Cut the single equation in two and treat it like two separate y equals mx plus b equations. You could put them into Desmos as separate entries and you'll get graphs of lines that are easier to understand. However, my main advice is to memorize this chart. If there's no x squared in either equation, then the question is mostly about memorizing facts and understanding vocabulary. These are questions you can probably get right in just a few seconds if you've confidently memorized the three possibilities. If the SAT twists the question so that you have just one equation, or if the lines are not in y equals mx plus b form, then do whatever you can to easily see the slopes and y-intercepts. You can graph the lines in Desmos to see the slopes without needing to rearrange the equations. But if the SAT only gave you one equation, I recommend splitting it into two before you graph it. These questions are fairly predictable and consistent on the SAT. You will almost certainly have at least one on every SAT exam. If you've memorized the chart, they should be easy points to add to your score. Just make sure you also watch my lesson on the number of solutions when there is an x squared, because that situation is a bit more difficult. Thanks for watching.